Hello guys, welcome back. First of all, Happy New Year and best wishes. I'm pretty excited to get this project started, so let's get right into it. Last time, on the last video, we've explored a bit how we can push the Zig build system to do what we want it to do. So let's take it from there, I guess. Right, so the first thing I want to do is basically just go up here, go here, and pick this, pick IO, pick logger, and serial, and I'll bring them to here. I'll probably get IO, logger, and serial into their own new folder. I'll call it log, and put them there. Maybe should have moved them. Yeah, let's do this and this. Yes, there we go. That should work. And with this, we can go back to main and do a little bit of const boot info is import boot info.zig, and we can do something like actually we can bring back const or extern const boot info, which would be a pointer to boot info. Right, and let's get rid of that. Do something like info right there. Let's get rid of this too. Do boot info. Let's do this correctly this time. Boot info, and still we are not using it. So boot info, and is it going to? Oops, there we go. And here we can actually get rid of. Oops. Okay, there we go. We can get rid of all these lines. So it shadows declaration of boot info. Okay, so bi. Right. Well, I guess we are doing pretty okay. I'm also going to const. Actually, I want to find main.zig on the Wi-Fi side and just pick this thing here. Put that there. Actually, probably do this. So now we are going to need to import stud, and that's pretty easy. We know how to do that. We also are going to need to import logger, which we just put into logs slash logger.zig. Oops, there we go. Cool. We want our default log for now to be debug, but we are still not going to be using this log as of yet. Right, so now that we have this going, well, let's get started with the main topic of today's of this video, which would be CPU identification and capabilities. So we want to know what each of our cores is capable of, because we can, in theory, we can run our OS on at the same time in parallel on multiple different cores that can have different capabilities. But for now, we are just going to postulate that all the cores are perfectly identical. The way we can get the CPU identification is by using the CPU ID assembly instruction. So if I go here, you can see that we have this CPU ID instruction. And this basically takes two parameters. It takes a parameter in EAX, which is usually called function, and in ECX, which I think is called the branch. And it basically returns information in all four registers EAX, EBX, ECX, and EDX. And depending on which function and branch we pass it, we get different information in those registers. So we can look here for some of the info it's returning, but it's actually gotten a whole lot complicated over the years. And I think that now we have over 800 bits, which describe over 800 different information. It's so complicated that we currently do need to auto-generate that if we want a complete view on how that works on all the fields. So actually, there's this project I found on the internet, which basically is a database, an XML database of all the leaves. So basically, CPU ID is sort of a tree. You give it a function and a subleaf or a branch, and you basically get all the info on those on that branch in the registers. So for example, here, if we take this leaf 0 as an example, if we set EAX to 0 and ECX to 0, we will get from the CPU ID in EAX the highest CPU ID standard leaf supported. We'll get back to that, or actually we can just ignore it. It's kind of useless. In EBX, we are going to get the CPU vendor ID string. We are going to get the first 4 bytes of that in EBX, then the next 4 bytes in EDX, and the next 4 bytes in ECX, for a total of 12 bytes for vendor ID or CPU vendor ID. And if we go down here, we can see some of the CPU vendor IDs, so authentic AMD or genuine Intel, something like that. Right, so we are going to use CPU ID to go through some of the leaves and basically parse some of the info that we are going to need. And the info, actually, some of them are pretty interesting. We can get information about the cache levels, what cache levels we can have access to, their sizes, different topologies that the cache can come in, and stuff like that. We can actually, I think we have some more info about the L1 cache and TLBs. Here we can get the number of associative ways, or number of ways it is associative, the number of or the size of cache lines, number of cache lines, stuff like that. So this one is for L1, this one is for L2, and we can get quite a bit of info about the CPU, but it's it's a lot. So the way I guess mainstream kernels would go about this is to take a database, sort of like this one, and auto-generate code from it. So this project here can actually generate C structs. So if you give it a leaf ID, it will generate a struct with the things, the bit fields that are given by that leaf ID. So it's definitely something we can explore if needed, but for now we are just going to keep things pretty simple. And by simple, I mean we are just going to get the info that we need, and probably not all of the info that we need today. We are going to just get some of them today, and we are going to enrich this as we go along. So let's get started, I guess. We want to get something like CPU ID maybe. Right. And in here we are going to get stud. Obviously, I not know what I want to do with this, but I guess the very first thing to do is create a function I'll just call CPU ID. This function will take something, and it will, I guess it will just return nothing, and we are just going to take a pointer to something, right? So I should call this registers, and this would be a pointer to some CPU ID result struct I'm going to create. And actually, let's do that right now. So CPU ID result is a struct, and this struct here will have, well, as I said, 4 registers, and each register is 32 bits wide. So let me just do this. This is B, this is C, and this is D. Cool, and this needs this. So we are going to go into here. And I guess we are going to do this. This needs some of that. And here I'm going to do CPU ID. Right, cool. So CPU ID, and now we are going to need to give it the inputs and outputs, but I forgot how to do that, so I'm going to take a look at this. Right, so let me just copy these, copy this, put this here. Right, so here we have quite a few inputs, or these ones are outputs. So these ones are outputs. We can do something like this, output B, and I guess this here we give it the, so this should be EBX, and here we give it the return variable, or rather the variable in which to write the return. And I guess here we need to write it to registers or regs.eax. Okay, so it refuses. So maybe I should create something like this. Maybe I should do something like this and just get rid of this, do this here, EBX, and so this would be, all right, we are missing this. And we should also be able to do something like B to B, okay, and this one would be B to C, and this one would be B to D. Right, and here we should probably do the same. So input A comes from EAX, and EAX comes from, well, EAX, I guess. Yeah, and in C would come from ECX, and that would come from ECX, I would guess. So here what I need to do is I'm gonna do something like this, and this EBX, so regs.ecx, and oops, regs.edx. Right, so here we are going to need to write those back to regs. So the EAX is equal to EAX, regs.ebx is equal to EBX, regs.ecx is ECX, and regs.edx is EDX. Okay. Right. So with this, I think we should be okay. So the idea here is to put the EAX and ECX values that we want to query CPU ID with into this regs variable before we call CPU ID, and then we call it with those variables, and we get back out the results in the same registers, and we get them back here. So the regs will be our query and our results at the same time, I think. We'll see if this holds up, but for now it seems like it's an okay idea, I think. Right, so this is CPU ID. Is there something else we need? I don't think so. So let's create a CPU.zig. And in this, we are going to get CPU ID, which is import CPU ID.zig. There we go. So here we are going to need some struct to hold the data we want. No, actually we want two things. We want a struct that will hold the raw data we are going to get from CPU ID. So let me do something like CPU ID info holder. And this would be a struct that will have sort of. So let's just create a basic info field. Just call it basic, I think. And here we are going to create 32 of them, and these will be of type CPU ID dot what do we call that? CPU ID result, I think. Yeah, it looks good. So we want 32 of those, and we'll see where we go from there, because we can basically add any number we want here. So this one is the raw CPU ID information. We also would like to have CPU ID. Yeah, CPU ID is such a loaded term. CPU info. Yeah, I guess CPU info would be okay. And here we'd like to have, or I'd like to have, my own representation of those data in something that's a bit more usable for me. So I'd have something like vendor string, which would be a so it's 12 characters plus A0, so it's 13. Let's round it up to 16. Let's do something like max vendor stir. Yeah, U8. And I think I'll give them all default values, or yeah, I don't think I need to. I also want to have a vendor enum, which would be CPU vendor. This would be an enum. Let me create this here. So CPU vendor is an enum, and this will be something like Intel, AMD, maybe unknown. I think we should remove that. There we go. There we go. Right, so this one needs that, and this one is going to complain that we don't have max vendor string. So max vendor stir is, as I said, 16, I think. Yeah, that looks good. So we also would like to have the brand string. which I think we have also somewhere here, processor brand string. Right. This string is specified in Intel AMD documentation to be null terminated. However, that's not always the case. So it's a 48-byte ASCII string. Cool. But this one here is not in our it's not in our basic ones. So I think we'll have to go up here and just do extended info there. So this brand string will have to be max brand stir of U8, of course. And if we do this, so this one here would become brand, and this one here will be 64. So it's 48, but I'm rounding up to something that's that has an okay alignment. So what else do we need? I guess we are going to need some flags to know if something or other is supported in our CPU. For example, I would like to know if SSE4 is supported by my CPU, and in EAX1 ECX, if I call CPU ID with EAX equals 1, and I look at the bit number 19 and or 20 in our ECX result, if bit 19 is set, we do support SSE 4.1 instructions, same for 20. And we do have quite a few interesting things that we would like to use, like the enhanced APIC and stuff like that. So this can be useful for us to probe the CPU capabilities. So let's call this CPU flags, I guess. Probably CPU capabilities would be a better name, but we don't care for now. So CPU flags is a struct. And I guess for now we just call it a struct. We'll try to cherry pick the info we put into here as we need them, I think. But for now, let's just keep on moving. Actually, let's do something like SSE bool, SSE2 bool, SSE3 bool, SSE41 for 1, and SSE for 2 as a boolean. This one here would be S. Probably do some AVX stuff, AVX1, AVX2, and we don't really care about AVX 512. Right, so we now can move on. So here I'm going to stop here, but to do add info about TLB, caches, probably stuff like, yeah, for now, let's just keep it like this. Oh, CPUs or core count. So we could actually, some CPUs do give us info about core count in CPU ID. Right, so now we want to create a function that we are going to call init, as we usually do. And this function here will just initialize a variable that we are going to call CPU info of type CPU info, of course. And I guess we could initialize that, and yeah, let's put it undefined. As always, I cannot type undefined. That's cool. And here we are going to do, so CPU info, I'm going to do stdmem dot zeros. I'll have std here, right? Const std is import zig std this. And here we should probably just, does it take something here? Comp time t, so CPU info, I guess. Info. Oops, there we go. Right, so now that we have this, we are going to, so I guess we are also going to create a variable info or row info, which is stdmem zeros of CPU ID info ID info holder. And we are going to use that by doing fill or fill row info. To that we are going to pass row info with an underscore. And after this, we are going to fill CPU info, to which we are going to pass row info and well, CPU info, I guess. There we go. So let's create our first function here, and actually this one I'll just mark it as pub now so I'll forget. So fill row info, it takes a row info, or it takes what, a CPU ID info, let's just call it info, which would be a pointer to CPU ID info holder. There we go. And it returns nothing, as it's just going to fill this in. So how do we go about this? So I think I'm gonna do something like this. So for 0 to 32, capture that as I. Get a variable cell, which would be info.basic at position I, or the pointer to that, actually. I'm going to set cell.eax to add int cast of I. Right. And I'm going to set cell.ecx ECX as an int cast of 0, just to ensure it's 0. And then we are going to call CPU ID with cell. So CPU ID would need to be CPU ID.CPU ID. Right, so yeah, it's that function there. And with that, this cell should now be filled. Right, and we should probably do the same thing, the exact same thing here for extended info here, but here we are going to do 8 triple zeros, 4 zeros plus. It would be actually cool if, so does that work? Okay, I didn't know about that. Cool, so with this, I think we should have what we need in as far as row info goes. So here we can do CPU info, and here we are going to take row info as a const pointer to CPU ID info holder. Of course, it's const because we are not going to modify that. We are just going to use it. And CPU info, we can't actually call it CPU info. We are going to call it CPU. Let's just call it info. It's a bit confusing. So I'm just going to rename this to row info, and this I'm going to call naming is the hardest part about computer science, especially if you don't have shadowing, because as we do have this CPU info variable here in our module, we will not be able to call any other variable or parameter in our module CPU info. Let's just call it CPU identification. Right. And what is this? This should be a CPU info struct, or a pointer to a CPU info struct. So here we are going to, let's start with the easy stuff. Let's start by just getting the vendor string. Right. So the vendor string is, we are going to get the row info. We are going to memcopy. So memcopy, and I guess we are going to do some pointer casting. We are going to memcopy row info dot basic dot 0, because if we go back here, all the way up here, so EAX0 is what gives us the manufacturer ID, and the manufacturer ID comes in EBX, EDX, and ECX. So the order is important. So we are going to memcopy EBX, or the first bytes in EBX, into the first bytes of our string vendor stir, then EDX into the next 4 bytes, and ECX into the last 4 bytes. And of course, we are not going to forget to put a 0 at the end. I say that, but I might forget. So EBX I said, but hold on, is this destination? Yeah, this is destination. So pointer, actually I don't need a pointer cast for this. So CPU identification dot vendor stir, and I'm gonna slice it because I'm gonna need to know how long that copy is. But overall, this should be okay. So I guess we are going to need to give it as so a pointer to const u8 is is what we need. So let's do that, and that should be pretty good. So if we just duplicate this, okay, hold on. Let me do a simple trick that can change lives. Let's do this, and then let's do. Oh, right. So this one is EDX and this one is ECX. Right, and we are not going to forget to put a 0 at the end. Identification dot vendor stir at 12. So the 13th byte should be a 0 to finish off our string. And I guess we are going to let's also fill our vendor field here also. So to do that, I'm going to create a const match table, which would be just basically an array of key values. So that would be a struct of key key, which would be a const slice, and value, which would be, in this case, vendor, CPU vendor. So CPU vendor. Let's call it let's call it vendor match table, because it's kind of specific to the vendor. So here we are going to go create a vendor match table, which would be basically an array of vendor match table. And in that array, we are going to create an entry, which would be, so key would be, let me take a look, authentic AMD. Authentic AMD, not ANC. And the value for that would be .amd. Right. And we are going to do this, and for Intel, it's genuine Intel. So genuine Intel. And here we should have Intel, and this one is complaining about this. What is it complaining about? Expected equals found right. Right, so let's just do this. Let's just do that. Can you, right. Cool, so now that we have our match table, we are just going to loop through vendor match table, get entry, vendor match table entry, and this would be match table entry. Cool. There we go, and here we are going to check if stud mem equals uwaits, of course. So A would be CPU identification dot vendor stir I guess it doesn't matter that the sizes are not the same, but I think I'm gonna do this either way. I think it stops at the first one, or does it not? Oh, okay. No, so I do have to slice it. So if this is equal to entry dot key, then we found our vendor. We can just set it. So CPU identification dot vendor is equal to entry dot value, and we can return, or rather, we can break from this loop. Otherwise, we keep on keeping on, I guess. And here we should probably just do identification dot vendor is set to unknown. Right, cool. Let's keep on going, I guess. So let's take a look at the brand processor brand string. So it returns the brand string in EX, EVX, ECX, and EDX. Okay. Okay. So we are going to need to call or check that we have in the leaf this. We have the value is not less than this, and I guess we could go here and we can go look at where is the brand stuff. I might be missing something here. Oh, okay, I wasn't reading the correct one. So the highest calling parameter is returned in EAX. EBX thingy returns the manufacturer's string, which is the same as what we already got, but it's AMD specific, so we're not caring about that. But we need to check that EAX is at least equal to this value here, so that we can then use the calls of these values to basically get the full processor brand string. Right, so let's do that. We want to check that row. So if row info dot base dot extended, and we know that it's the extended 0 that we are looking at. Dot EAX is above or equal. Is that what they say in? It should be at least that the wording value is not less than. So it should be equal then. If it's not less than, it should be equal. So if this equals to something like this, 004, we can go ahead and take a look at the brand ID. So let me go back here and we go from 2 to 4. So we have 12 or 16 bits times 3. Right, okay. 16 bits times 3. So 4. So 2 to 4. As capture that as offset, I guess. We are going to compute yeah, so const leaf is CPU or row info dot extended at 0x yeah, so we can do that. Something like this plus offset, right? And we are going to take the leaf and copy that into our so we are going to memcopy the into CPU identification brand string at offset 0, or starting from offset 0. So we are going actually to also need Right, I'll think about this. I'll think about it in a bit, but for now, let's just get row info, or rather, it's leaf dot EAX. Okay, so here we do have a problem. So we need these to be pointers. Yep. Oops. We do want that. So let's change this to be as a pointer to consuate pointer cast of row of leaf dot EAX. And this, I think we can just use as a pointer. Yeah, it looks pretty okay. Actually, we don't really care about how this is used. It's on the stack anyway, so yeah, it's fine. Right, so we should do that, and then we should do this starting from, actually, so this offset here would be 0, but it's 0 plus offset minus 2. Right, let me think about this. So it would be 0 offset minus 2 plus, or rather times times 4 times 4. So basically we have 4 bytes in every entry here on our leaf. Or actually we can just call this to add size off, or bit size off, I guess, would be a bit more a better use, better, more careful use of what we want to do. And this would be CPU ID dot CPU ID result. Right. So this would be 16 bytes, because we have 4 fields of 4 bytes each. And here we want this to be copied to so for the first, for 8000002, which would be our first iteration, we want this to be copied to byte 0 of brand string. And here we want this to be copied to, so let's copy this. And this we want to be 4 plus, right? So this would be 4 plus the offset minus 2, which in our first iteration would still be 0. So it'd be 4. And then we are going to want this to be 8. And then we will want the last one to be 12. So in our first iteration, this would be 0, 4, 8, and 12. On the second one, the offset would be 3. So this would be 0 plus 16. So it's 16. 0 plus, or rather 4 plus 16. So 20, 16 plus 8, and 16 plus 12. So this would auto increment the offset to which we want to write. Right, so let's not forget to actually do this and this. Hopefully this works. Hopefully this works. And of course, here we should go ahead and do identification, because they say it should be 0 terminated, but I'm not trusting them. So the 48-bit would still be 0, as far as I'm concerned. Right. So I guess we should have enough to work with here. We haven't looked at filling up the flags, but that's fairly easy. We just need to get bits and probe them and put different flags to true if they are set. So let's build this and see where we go from here. All right, let's build this and see. Of course, it does not work. So I have the very latest master version of Zig. I still haven't pinned this project to any Zig version, and I think this is a quote-unquote regression due to that. So we do have a it's in fs.zig 43, fs.zig 34, sorry, not 43. So this here is a pointer to UEFI protocol file, as we can see here. And it's not liking the fact that it's called, or we call open volume, which takes a pointer to double const file protocol with that. So I think I'm just gonna slap a pointer cast there and call it a day. Looks good to me. So we have the same issue on line 55, same file, line 55. File handle, is that what the problem is? So file handle, where is file handle? Okay, so pointer, pointer cast. Right. Okay, she builds. Right, so let me just do, actually, let me just split this vertically and do LVM opsh dump, so dash D, dash M Intel, and I want to dump kernel 64.elf. Right, so we are jumping to what? Oh, cool. Very cool. We haven't used any of the things we worked hard on. So CPU is import CPU, let's say. Right, and here we can just do CPU.init. Right, let's try this again. Cool, so now we do have errors. CPU result ID is not marked as pub. CPU result, CPU ID result. Yes, this one should be pub, and this one also should be pub. Right. Type const thingy is not indexable pointer. What? Okay. So that's, I guess, in CPU .zig, and that's somewhere over here. Right, so I guess we just need to, oh, no, hold on. We just need to tell it that it's this. It's a multi-item pointer of const 8. Right, so same problem here, 81, so 81. Yep, exact same problem. So I'm just gonna do a bit of this by hopefully this doesn't. Yeah, let's. So this const gets replaced by this const. There we go, and we should apply the same thing here. So this const gets replaced by this const. There we go. Okay, so she builds again. Let's do this again. Go back here, call kernel main, and we go to kernel main, and we see that we have. So we move EAX into EAX, or rather we XOR it, because it's 0, and then here we set to 0, and we keep on keeping on. So this here is all the CPU IDs that we do. We do 32 for the basic ones and 32 for the extended ones. And for some reason, we just pop and ret without doing anything with that. Not sure that's what I intended to have. What's going on here? Is it because this here is not public? All right, let's make sure that we do get useful results. We are still, the code is still getting aggressively cold. So why is that? Why is that indeed? I guess I could just force it to be used. I guess I could do something like CPU info dot actually can I not just do std log info CPU vendor ID something like this, and then do CPU info dot vendor str. I think that should make some difference. Clear dump. Okay, let's see what we do get. It's still not doing anything with it. Very weird. Very, very weird. Is our log function doing anything? I think it does. Okay. No, it's still not doing anything with that. Am I going crazy, or is something not working here? Yeah, I'm gonna get rid of the fast release build. Hold on, what is this? Relocations? I don't want relocations though. What do we have here in our build? Set linker path, pick. So that's true. Pick is for position independent code or compilation. So it should not bitch about relocations if we tell it to just generate position independent code. And it's generating a bit more code now that we did. So let me just pipe that to more and see what we do have here. Right, so we do have some stuff. We do have our CPU.init here. We do have our calls to fill row info. So I guess if we follow that through, we should see fill row info there. We should see our call to CPU info, or I guess did get inlined. I don't think so. Yeah, but at least we can see that our code is actually getting generated there. I'm actually, yeah, I want, this is what I wanted to see. I want to see CPU ID. So we do move into EAX and ECX our values. We call CPU ID, and then we move the results from EAX, EBX, ECX, EDX into our temporary variables. So that looks pretty okay. I'm just gonna go back here and enable release build. Okay. The reason for that is just I just want to see if our code is actually still in cold. Huh. Right. So it's still again absolutely removed from the release build. For some reason. Yeah, I'm not sure why though. Let's bring back just the debug build. And we will use that, I guess. So QEMU, actually, I don't really feel like typing that. Yep. So let's create this. Let's do something like this. Rename W GDB, and we just start GDB there. So target remote 134 and file. Let's load the what's it called? The symbols from our kernel file, and let's break on start. Cool. And let's continue. Okay, so we do have we are going to have a nicer time working on our kernel because we do have full access to a debugger. So what I want to do is actually go back to my code, go back to CPU here, and go back to here. So I want to put a breakpoint at line 41 of CPU.sig. So GDB. So breakpoint at CPU.sig 41. Was it 41? It was 40. And let's continue. Okay. So I'm not sure if it's doing something. Okay. Are we not hitting that? Okay, that's kind of weird. So let's start it again. So target remote 134 file build kernel 64.elf, and if we do this, yeah, we should be okay to continue and at least hit the breakpoint in start. So let's step into this just to see if we can. Right, so step into that. Yes. Next. Step into that. Next. Next. Huh. So we do have a problem there. What is it doing? Okay, so we do have a problem with this. CPU info. So what is going on? Let me just put in default values. Right, so let's do stat.mem. Let's do something like this, and do max vendor stir. I don't think I need this though. I guess I do. And here I should do the same. Something like this, and max brand string. And this would be stat.mem zeros of CPU flags. Right. I'm not sure what this is doing, but for some reason it has issues. Right, so let's do this equals to that. Get rid of that. Let's stop this and let's rebuild it. Okay, let's exit from this. Redo GDB, target remote 134. File is in build kernel 64.elf. And do we have any? We don't have breakpoints, so we do start, and we continue. Right, so we step into that. We go next. We step into that. We go next. We go next again. Huh. It's kind of weird. Let me just get rid of that. Let me do a bit of a cleanup. Let's take a look at our thing here. Okay. Let me just force an alignment for read-only data. See if that's of any help. Oh, wait, hold on. We do have a problem here. VMM overwriting a present entry. What is going on? Oh, so we do have issues, I guess. Okay. Right, let's see if we are getting the same problem. Right, so let's do this again. Target remote before file build. I should probably create a GDB script. And we set a breakpoint on start and we continue. Then I want to go back here. Okay, so we do not have that same issue anymore. Let's keep going, I guess. So step into there, next, step into there, and hopefully this doesn't break anything. Next, okay. Okay, so I think the issue was that we were overwriting a, one of the segments was not page aligned, so we were rebinding it on a used page of our virtual memory, so that basically messed up our kernel loading. Right, so let's just skip over this. Let's do something first. Let's do print CPU or row info. So it's all zeros, as we can see here, it's all zeros, as we expect. And if I go over this, basically execution here, I should do row info. And this one here should have some values in it, which is pretty okay, I think. If I do px row info, just to see them as hex, for example, and we can see that extended here. Right, so probably should go back to code, and we do have a bit of an issue here. So here I've put this, but I actually should have put something like this. Right, so let's go again. Let's build this, and we are going to relaunch that, and we should just exit GDB, same again. And actually, this time I'm going to just do something like this. Line 40, if I'm not mistaken, I should just do this and see. Yes, line 40. That's pretty cool. So I should do this and continue, and I should find myself at line 40. Yes, very cool. So if I do now px of row info, so we do still have the same data, but now we are going to step into our fill CPU routine here. And so now we are going to try to copy the first, or copy some of the bytes in to vendor string. So let's execute that, and let's take a look at, so print CPU identification, not type in that, but vendor string. Okay, so the first 4 bytes are looking good. So let's continue. Let's go over the whole thing. Let's set the 0 also. Let's reprint that, I guess. And we do have authentic AMD. Very cool. So now let's create our match table. Or actually, our match table is already created. Let's keep on going. If we just do next here and we print entry, there we go. So we do have our match table. Right, so if we keep going here, we should probably find a match on the very first item, because we have authentic AMD, and we should set our thing here to, so vendor would be AMD. So if we go print CPU identification dot vendor, we should see AMD, which is the correct one. Right, so here we are going to take a look at our extended info. So we do fulfill the first check. So now we are going to go into here, and we are going to get a leaf. Okay, my bad. Yep, that's my bad. That's totally my bad. We don't really need to do this. Oops. We do not need that. We just need the offset. Okay, let's rebuild this and see where we go. So I guess target remote. Let's reconnect. It doesn't want, of course, and let's reload our kernel file. I think we don't really need to reload it, but yeah, it should be fine. So cool. Let's keep on going. Right. Let's now step into this, and let's set a breakpoint where we were before. So where was that? It was somewhere over here. So 78. So b cpu.zig 78. And there we go. So now let's just next it. Yes, let's get the leaf. Let's print the leaf. Leaf. Okay, we do have some data on that. Let's memcopy the first one, second one. Let's go the whole loop. And when we come back over, we are going to print CPU ID identification.brand stir. Okay, so we do have QEMU virtual CPU, but let's keep going. So next would be, okay, are we doing something crazy there? I think we are doing something crazy. I'm gonna get rid of this. I'm just gonna replace it with a straight up 16. Of course, we need a space there. Oh yeah, of course. It needs that, and this needs that. So let's do something like this, and we can do that. We can do this. So hopefully that does not cause more problems. Let's see here. Let's get rid of view, and let's go back again. So target remote 134. Of course, it fails, and we do the same again. Cool. So here I'm going to put a breakpoint at CPU.zeg line 80. And I'm going to remove the third breakpoint. And I'm going to continue. And again, I'm going to continue. And here is where we had the problem. So let's just step into that this time. And let's hit continue. Uh-oh. Guess we do have the same problem again. Or not, maybe we don't. So print CPU info. Cool. So we did not break for some reason, but I think we should have the full brand name. So let's just restart QEMU and we'll see. So let's connect again. Target remote RV4. Of course, broken pipe. And let's load the symbols again for good measure. And we should be able to, actually I'm gonna add a breakpoint to main.sig at line 21. Let's continue. Okay, so this is 2, this should be 3. Is 4 not included into the offset? Is my question. So what happens if we go all the way? So first of all, let's print offset. Offset is 3, of course. And if we go back here, yeah, so we are not executing 4. Right, so I guess, do we have something like this? I don't think so. So we should be doing something like 5. Right, okay. Cool. So let's re-execute that again. Go to our GDB, do the same thing. Again, broken pipe, load our file, and we should still have our breakpoints. Let's continue. Right, so that's our first breakpoint, and this should be, so if I print offset, so let's deprint offset. Yeah, forget that. So if I just print offset, I should have 2, and I should continue, and I should print print offset again. Should have 3, and I should continue, and I should print offset again, and I should have 4 this time. Cool. So I am going to keep on going, just next it. And here we should hit that again. We should go down there. We should set our 0 right there. And now we should print CPU, can I do this? CPU info. Okay, so we are out of context. So CPU dot, so info locals, no locals. Really cool. So let me just try something. Is there something like breakpoint? Okay, let's do something like that. Get rid of you. Do something like target remote 34. And just for good measure, I'm just going to add a breakpoint at del 3. Cool. So just want to print CPU info. That's all I want. Oh, it's CPU identification. Identification. Okay, that's cool. So let's get that. Oh, there we go. So it's QEMU Virtual CPU version 2.5 plus. Cool. So we do have everything that we need, which is pretty cool. Right, so this looks like it's working pretty nicely. The only issue that we have is that the log is not logging for some reason. Yeah, we don't see the logs, but that should be pretty okay. Well, that's pretty much it for this one. I'm gonna stop the yapping here. Hit like, subscribe, all the good stuff. Leave a comment if you want to see more, or if you have questions, you can also ask them on the Discord. I promise I'll try to be more active there. Until the next one, I'll see ya. Fucking out.